Hello everyone, this is Waghmare, Department of Mechanical Engineering, YV Patil Polytechnic, Akodi, Pune. So in today's session, we will see the part 3 of unit number 2, that is high pressure boiler. In the previous session, we seen different types of high pressure boilers. Okay, in that Lemon boiler, then Benson boiler and Loeffler boiler. We studied its construction, working advantages, disadvantages. Now in today's session we are going to see remaining types of high pressure boilers. Okay, so the first type is Schmidt-Hartmann boiler, then we will see Velox boiler, Ramsin boiler. Okay, we'll see its construction, working advantages, disadvantages. Okay, so let us start with the first boiler, that is Schmidt-Hartmann boiler. Okay, Schmidt-Hartmann boiler, this is a high pressure boiler. This is a high pressure boiler. What is the definition of high pressure boiler, or how we can define high pressure boiler? If the steam generating capacity is more than 80 bar, then this type of boiler we can say it as a high pressure boiler. If it is less than 80 bar, steam generating capacity is less than 80 bar, then we can say it as a low pressure boiler. So this boiler is also a high pressure boiler. Here two circuits are used. Okay, two circuits are there. First is primary circuit and second one is the secondary circuit. Okay, primary circuit and secondary circuit. In primary circuit, the steam generated is up to 100 bar. Okay, and in secondary circuit, the steam generated up to pressure of 60 bar. In this boiler, working operation is similar to an electric transformer. Two pressures are used to effect an interchange of energy. Okay, now we will see its construction. A Schmidt-Hartmann boiler. Okay, this diagram or this image shows the Schmidt-Hartmann boiler. Now we'll see in this image how the Schmidt-Hartmann boiler works. Okay, now first of all, see its important component. By observation, you will find this diagram is very difficult, but just try to understand this. It is very simple diagram. Okay, now see first important components. First of all, two circuits are there, primary circuit and secondary circuit. Okay, so first here you can see here this is a feed pump. Okay, feed pump. This is a primary circuit. Here it is a primary circuit is there. Okay, which one is the primary circuit? This is a primary circuit, and this one is secondary circuit. This is a secondary circuit, we can say, right? This is a secondary circuit. Now I will explain its working, right? Primary circuit, secondary circuit. First we will see components. Feed water pump, this is a feed water pump. Then here it is one component, that is a feed preheater. Okay, preheater of the or preheating of the feed water takes place inside this preheater. Okay, then this is a evaporator drum. This is a evaporator drum. This is about the primary circuit. Now we will see secondary circuit. This part is the water drum. This part is the water drum in the secondary circuit. Then here it is a pump is there. Okay, this is a pump. Then next component is, yes, this is a evaporator, primary evaporator. We can say it as a primary evaporator. Then in the primary circuit, next component is the primary separator. Okay, primary separator. Then here it is one coil which is placed in the evaporator drum, right? So this is about the primary circuit and secondary circuit, components of these two circuits. Now as usual, remaining components are superheater. Okay, this coil is nothing but a superheater. This superheater is placed in the path of flue gases. Actually here it is a combustion chamber, so combustion of the fuel takes place here. and these flue gases flows in the upward direction. So this is the location of this superheater, which is placed in the path of flue gases. Okay, then after this superheater there will be a prime mover, or we can say turbine. Now next component in this Schmidt-Hartmann boiler is air preheater. This component is known as air preheater. This is also placed in the path of flue gases. Okay, and function of the air preheater is to preheat the air. Okay, how that preheating takes place? By absorbing the heat from the flue gases. Generally we take the, or this blower takes the air, atmospheric air, and it's sent to the air preheater, and this air preheater heats the air and send it to the combustion chamber for combustion purpose, right? Why that air preheating is required? To increasing the efficiency of the power plant. Because of the air preheating, the amount of fuel required to generate the heat will be less, so ultimately increase in the efficiency takes place, right? I hope you understood the construction. Okay, important components of the Schmidt-Hartmann boiler. Now I will explain its working. Okay, I will explain its working. See here what happens. From the water sump or water well, the cold water sends inside this preheater by using the feed water pump. Okay, in the primary circuit. This is a feed water pump which is placed in the primary circuit. So the feeding of the water takes place here, and then this water or this tube is surrounded by the steam, hot steam, which is having a very high temperature and pressure. This steam gives heat to the cold water, and this water becomes a saturated water here, right? Saturated water, or we can say saturated steam. Okay, it enters into this evaporator drum. Here it is a mixture of water and steam is there, or water and water vapor is there, right, in this evaporator drum. Now what happens? We are sending a steam from this primary separator through this pipe here. This steam is having a very high temperature. It gives heat to this water, which is, or we can say saturated steam, right, where the separation of the water and steam takes place, and this steam we can send through this pipe to the superheater coil, or towards the superheater coil, where the superheating of the steam takes place, and this superheated steam we can use for power generation purpose by using a turbine and generator. Okay, now what about the secondary circuit, right? This is the primary circuit. From this point to this, and this steam goes up to the turbine. Okay, this is the primary circuit. Now secondary circuit. Here we are sending a steam from this point. Okay, it is this water or this tube is surrounded by this steam. By giving heat to that water, the steam becomes condensate, that is liquid form. Okay, and this water is stored in this drum. Okay, water drum, and this water we lift by using this pump, feed water pump, and we send it into the primary evaporator coil or primary evaporator tubings, where the heating of the water takes place. Why? Because this tubing is placed in the combustion chamber, right? It is placed in the combustion chamber, so heat exchange takes place between the cold water and the flue gases, and this water becomes saturated, and or temperature and pressure increases, and it is entered into this primary separator, where the separation of the water and steam takes place, right? water and steam takes place, and this steam we send into this evaporator drum, okay, to this pipe. So this pipe is surrounded by the saturated mixture of water and steam here, right? So here it is, heat exchange takes place between this high temperature steam to this saturated water, right? So this steam, this water converted into steam. Now after giving heat to this steam, this water enters into the feed preheater, right? Feed preheater, where again here it is exchange of the heat takes place between this cold water and this steam, and it is converted into condensate or liquid, right? So in this way the secondary circuit also completed, right? So this is about the construction and working of the Schmidt-Hartmann boiler, and the remaining part or remaining working of the Schmidt-Hartmann boiler is same, that is how the air preheater works. See here, air preheating takes place in the air preheater, and all these components in the sense this evaporator, then this superheater and this air preheater are placed in the path of flue gases. These flue gases we can send through the chimney into the atmosphere, okay. So maximum efficiency obtained by the high pressure boiler is up to 35 to 40%, okay. By utilizing some other devices we can increase it up to 70 to 80%. We'll see it later, means which devices are used or which arrangement is used to increase the efficiency of the boiler, okay, or thermal power plant or any power plant. We'll see it in another unit, right? So this is about the working of Schmidt-Hartmann boiler. Now we'll see advantages and disadvantages of the Schmidt-Hartmann boiler. So first point is, any deposits in evaporator drum due to impure water can simply brushed off by removing the submerged tube edge of the drum or by blowing off water. Okay, what is the meaning of this? In this diagram you can see this is a evaporator drum, okay. Here we are sending the water, saturated mixture of water and water vapor. So whatever the sediments or impurities present in that water, that impurities can be easily removed by taking this tube outside of the evaporator drum, okay. Means it is very easy to remove the scale formation or sludge formation on this tube, right? So for maintenance purpose it is very easy. The next is as it can use impure water, there is no necessity of water softening plant, eventually reduces cost. Means we can use this type of boiler where the impure water is available, okay. So there is no requirement of another softening plant, water softening plant, okay. So it eventually reduces the cost. Then next is it can utilize impure water for creation of steam, right? Impure water can be used. Then disadvantages of Schmidt-Hartmann boiler. So first disadvantage is evaporating drum is used, which increases the size of plant, okay. Evaporating drum, this is one extra component added as compared to other type of boiler, right? So this is disadvantage. Then due to deposits in evaporator drum because of impure water, plant has to stop often for cleaning purpose. Means intermittently we have to stop the plant. For what purpose? For cleaning the evaporator drum, right? Because there are chances of formation of the layer, or we can say scale or sludge formation on the tubings of evaporator drum. Okay, so to remove that formed layer, we have to stop the plant intermittently. This is the disadvantage. Then next type of boiler is Velox boiler. Okay, Velox boiler. This is also a high pressure boiler which generates the pressure more than 80 bar. Okay, this was invented by the Velox, right? Then working principle of this type of boiler: when the velocity of the gas is greater than the speed of sound, its heat transfer rate is also increase. Okay, so more heat is transferred from gas to water as compared to when the heat transfer at the subsonic speed. Means the working principle used here is, in the combustion chamber, when we pass the, or when we increase the velocity of the flue gases over the tubing of water, okay, over the water tube, when we increase the velocity of the flue gases, then heat transfer rate increases. This principle or this phenomena is used in case of Velox boiler. If you see in this diagram, this arrangement is somewhat horizontal type. Okay, horizontal type means components are arranged in horizontal manner, not in a vertical manner as compared to other type of boiler, for example Bunsen boiler, Lemon boiler. Okay, so all these types of boilers are somewhat vertical type, but here it is a horizontal arrangement is there. Now we'll see its construction and working. Okay, Velox boiler. This image shows a Velox boiler. Now we'll see its component first. This is a combustion chamber. Okay, this is a combustion chamber on which these tubes are located. This is a combustion chamber on which tubes are located. Here it is, a compressor is used. For what purpose? Compressor used to send the compressed air with high velocity in the combustion chamber. Okay, in the combustion chamber for burning the fuel, right? Then this is the path for the flue gases. This is the path for the flue gases. Flue gases in the sense burned gases. This one is turbine. Okay, we can say gas turbine. How it runs? By taking the pressure energy of the flue gases, this turbine runs. Okay, and on the same shaft of the turbine, here this compressor is mounted. Okay, means common shaft is there. Means some energy of the turbine or the energy generated by the turbine is taken by this compressor, okay, for working, right? Then this is the exhaust or outlet of the flue gases. This is the exhaust or outlet of the flue gases. Then this is a feed water pump. This is a feed water pump. This coil is the economizer coil. This coil is the economizer coil. Then here it is, a feed water circulating pump is there. Feed water circulating pump. Then next component is the steam separating drum, or we can say boiler cell. Steam separating drum or boiler cell. Then after this, here it is a superheater coil. This is a superheater coil which is placed in the path of flue gases. Okay, this is combustion chamber. Combustion of the fuel takes place below this tube, and this is the path of flue gases, and in the path of flue gases this superheater is located. Okay, so this is about the construction of the Velox boiler. Now how it works. How it works. First of all, here it is, combustion of the fuel takes place in the combustion chamber. Before that, see here, this is the path of flue gases. This is the path of flue gases. Now we send the cold water by using this feed water pump inside the economizer. As this economizer is located in the path of flue gases, it absorbs, this water absorbs heat from the flue gases and it becomes hot, means temperature of that water increases. this hot water or increased temperature water can send into this evaporating tube by using the circulating pump, right? So these tubes are located above the combustion chamber. So here it is, heat exchange takes place between the high velocity flue gases, and this water becomes saturated. Means temperature and pressure increases, right? And this saturated water is stored inside this steam separating drum. Okay, steam separating drum, where the separation of the steam and water takes place. Then the remaining water, we again send it into the evaporating section by using this pump. Means we are taking water from this side also and from this side also, right? And what happens to this steam? We send this steam, saturated steam, through these pipes inside the superheater. Okay, so the superheater is located in the path of flue gases. So exchange of heat takes place between the superheater, the superheating coil, or we can say saturated steam, and the flue gases. Okay, and this superheated steam we can send it to for the power generation purpose, or we can say for running the turbine, right? This is turbine, and this one is a generator, electric generator. Here it is, electric generator will be there, and after this transmission lines. Okay, by using the transmission line we can send this electricity or power towards the consumer, right? So in this way the Velox boiler works. Now see, after giving heat, these flue gases, heat energy to this steam, these flue gases, we send it on to the turbine blades. Okay, where the turbine gets rotated, or this rotation of this shaft takes place. And here it is common shaft, and because of this common shaft, the compressor compress the atmospheric air, and this compressed air we utilize it for combustion purpose. Okay, now working principle, what its working principle says: the high velocity burned gases, if we flow on the tubes, then there will be a high heat transfer rate. Okay, so same function is carried out by using this high velocity air. Okay, so in this way the Velox boiler works. Here also we can see this by using this symbolic arrows. Blue color shows water, okay, cold water. This is cold water, then this is hot water. Here this is hot water, here also hot water, this is hot water, right? Then next is flue gases. This path, or we can say this dotted line is nothing but path of the flue gases. Then saturated steam means mixture of water and water vapor. Here after taking heat from the burnt gases, this mixture become saturated, right? Then superheated steam, very superheated steam, after taking heat from the flue gases, this steam becomes superheated. So this arrow. Okay, so this is all about the Velox boiler. Okay, I hope you understood the working and construction of the Velox boiler, right? Now next point is we will see its advantages. This boiler has high heat transfer rate. Okay, why? Because high velocity air is we are sending it into the combustion chamber, so high heat transfer rate. Then it has a great flexibility. Okay, great flexibility means we can change its design, right? It is easy to control. It is fully automatic. It has thermal efficiency about 90 to 95%. Okay, disadvantages: extra ground surface or space is needed. Why? Because as I have already told, its construction looks like somewhat horizontal type. right? Horizontal type, so it require more space. Then fuel oil burning power station lies in the high cost of fuel, right? It can only operate on liquid or gaseous fuel, right? Not on the solid fuel. Then now next point is Ramsin boiler. Okay, this is one simple type of boiler, but this is a high pressure boiler. This is a high pressure boiler, or we can categorize it as a once through boiler. Once through boiler. Then forced circulation type of boiler. Okay, why forced circulation? Because for circulating the water, feed pump is used, right? Then I will explain its components and then working, right? So this is a feed pump, then this is a economizer, this is a evaporator, this coil is evaporator, then this is a superheater. Here it is combustion chamber, okay, where the combustion of the fuel takes place and the flue gases flows in the upward direction, now these components are located in the path of flue gases. Which components? Evaporator, superheater and economizer, right? Now what happens when we send the cold water from the well to this economizer, where the preheating of the water takes place. This preheated water, we send it into the evaporator, where this water becomes saturated, that is mixture of water and water vapor. This again send it into the superheater coil, where the saturated mixture become superheated, and this superheated steam we can utilize it for power generation purpose. Okay, so why it is a once through boiler? Because at one end we are sending a cold water, and at the other end, right, at the other end we are getting here a superheated steam. So this is a single pass or single stroke. Within a single stroke we are getting a superheated steam. So this is a once through boiler, right? So this is all about the construction and working of the Ramsin boiler. Now its advantages: this boiler has high rate heat transfer rate, it has a great flexibility, it is compact in design. Okay, it is compact in design, it is easy to control, it is fully automatic. Then disadvantages: fuel oil burning power station lies in the high cost of fuel. Okay, so all these are the advantages and disadvantages of the Ramsin boiler, right? Now in today's session we covered which points or which type of boiler: Ramsin boiler, Schmidt-Hartmann boiler, and then yes, which one is that? Velox boiler. Okay, so these three boilers we studied. Now this is all about the high pressure boilers. Okay, now we'll stop here. So thank you very much for attending the today's session. Okay, thank you very much.